All right, welcome to part 3. There's 3 questions here that are all worth 4 points, and we'll show you some easy ways to take care of these. So for this first one, this is all from level 4. All right, this is a level 4 question where we learned about parallel lines. You might remember there's 4 kinds of angle pairs that we learned about. Alternate interior, 2 would be alternate exterior, 3 would be corresponding angles, and 4 would be same side interior. We know that these 3 are all incongruent when the lines are parallel, and we know these are going to be 180 degrees or supplementary. This question, though, is asking us to prove how we know that these lines are parallel. All right? So we want to find either alternate interior, alternate exterior, or corresponding angles that are congruent. But remember, we can't use them in our proof. So I'll show you a very quick and easy way to do this problem and get the full points on it. So if you read the question, it tells you first that GH is congruent to HI. So we have a nice little isosceles triangle here, GHI. It also tells you that EGB is 50 degrees and DIG is 115. And let me show you how you can take care of this proof pretty straightforward. All right? So we're going to make a little chart here because it tells us to explain. So we want to explain everything that we do. All right? And we're going to put the angle name, the measure, and the reason for each angle we fill out. Now, the first angle is going to be 65 degrees right here, all right? So this is angle HIG. It's 65 degrees, and the reason is because linear pairs are supplementary. Pairs are supplementary, right? This is to make a straight line, so they must be supplementary. Now, the next angle I'm going to fill in is right here. So you fill in an angle, and then you explain why you filled it in. And so that's angle HGI. And that's also 65, and I know that because base angles of a isosceles triangle are congruent, right? These 2 are the base angles. And then finally, I'm going to put 50 degrees right here, all right? And this is angle GHI, and this is 50 degrees. Now, the reason I know this is 50 degrees is because of the triangle sum theorem, right? We know that all angles are going to add up to 180. 65 plus 65 plus 50 equal 180. Triangle sum theorem. All right, there we go. So that we got 180 right there. Now, we could actually answer the question right here because we actually have corresponding angles. But some people don't see corresponding angles very easily, so I'm just going to do one last angle because even though we've answered it right here, I'm going to add one more in. And let's put 50 degrees right here. So angle CHF is 50 degrees. And that's because the vertical angles are congruent. With that information, I can now make my proof, right? I can make this statement with confidence that AB must be parallel to CD because alternate exterior angles are congruent. So I've proven by filling all these angles, not using these properties right here, but just filling in the angles with other theorems, that I have alternate interior angles that are congruent. And so let's actually say those angles. We want to state the angles as well. Angle CHF is congruent to angle EGB. These are alternate exterior angles. All right? So remember, we state alternate exteriors and we explain which angles we're referring to. For our next one, quadrilateral ABCD is a parallelogram with diagonals AC and BD that intersect at E. Proof AED is congruent to CEB. Well, this is a level 5 question. This is parallelograms. And you actually learned how to do parallelogram proofs in 5.4. That's actually where we learned parallelogram proofs. Now, there's many ways you could do this proofs. I'm just going to show you one of the ways, and there's many other ways to do it. Don't think that if you did a different way, you did it wrong. So I'm going to start by marking vertical angles. Then I'm going to do opposite sides are congruent, and then I'm going to do alternate interior angles. All right? And so what I've shown here is that I have 2 triangles that are congruent because of angle side. All right? So let's write out that proof now. So we have statements and reasons. 1, ABCD is a parallelogram, and I know that because of, it's a given. 2, I know angle AED is congruent to angle BEC, and that's because of vertical angles are congruent. Now 3, let's just keep talking about what we know. We know AD, this is what else we marked, is congruent to BC. We marked that because opposite sides in a parallelogram are congruent. And next, most people would say, okay, let's talk about the alternate interior angles. But we don't know alternate interior angles are congruent until we know that the opposite sides are parallel. So first we have to state that these lines are parallel before we could talk about alternate interior angles. So I'm going to say AD is parallel to BC because alternate interior angles, sorry, that is so wrong. I meant to say, I'm skipping to the next step. So let's say that again. 4 AD is parallel to BC because opposite sides are parallel. Now I can state, all right, now I can state this. 5 angle DAE is congruent to angle BCE. That's alternate interior angles are congruent. And then now I can finally state triangle AED is congruent to triangle BEC because of angle side congruence. And then finally it says describe a single rotation that would map it onto each other. I would just do a rotation 180 degrees counterclockwise around point E. All right, for our final part 3 question, there's 2 problems that you need to solve for this one. The first one is that you have to find the distance from P to L. Now, this question is actually pretty straightforward. To solve for P to L, what you should start by doing is just redrawing this triangle. We're going to take a closer look at that. So we're going to redraw it over here, like so. And we got LPC. We got X over here, 90 degrees over here, 0.25 over here, and 0.55 here. Now, just to find what PL is, you don't have to do anything fancy. This is literally just the Pythagorean Theorem. That's to find the missing side of a right triangle. So it's the formula is A squared plus B squared equals C squared. And we're just going to plug in what we know. So A is X, B is 0.25 squared, and C is 0.55 squared. And remember, C is always the hypotenuse. Now, if you solve this out, I'm assuming you could do this, you're going to get X squared is equal to 0.24. And then X, you take the square root of both sides, you're going to get X is equal to 0.49. All right? So that's our first distance. So the length of PL is 0.49. Now the next part of this question is a little more difficult. It says, Gerald believes that the distance from the first aid station, which is over here, to the campground site, which is over here, is 1.5 miles. Is Gerald correct? So what we were going to have to do is find out what is the length of FC here. And to do that, we have to split up these triangles. And we're going to split into 3 different triangles. A big one, a medium one, and a small one. So we got our big triangle, medium triangle, and small triangle. And we're going to relabel these. So remember, the right angle always goes here, and our shorter side will always go on this side. So we'll start with our big triangle. This is right over here. And we're just going to fill in where the right angle is, which is right here at P. The shortest side is PC, and the final point is F. For our medium triangle, which is right over here, we have our right angle at L. Shortest side is PL, and F is our final point. And then for our smallest triangle, which is this guy right here, we know we have L is our right angle, LC is the shorter side, and then P is the final point. So now we're going to fill in what we know. Now, we're looking for CF, which is our X, so X goes right here, and PL is 0.55. So that's what we know about our big triangle. On our medium triangle, the only thing that we know is PL, which is 0.49. And then for our smallest triangle, well, the shortest side is 0.25. The The hypotenuse is 0.55 and LP is 0.49. All right. Now to solve for this, what we're going to do is just set up the ratio of the corresponding parts. So we know x corresponds to 0.55, so that's x over 0.55. And then where 0.55 is to 0.25. So we're going to set up that next part of the ratio. What you're going to do is cross multiply this. You get 0.25 is equal to 0.25x is equal to 0.3025 here. Divide both sides by 0.25. You get x is equal to 1.2. So the question here that we're trying to answer is Gerald believes that the distance is 1.5 miles. We've just solved it and we see that it's 1.2 miles. So the answer here that we're going to write is Gerald is incorrect. The distance is 1.2 miles. All right, check out the next video for part 4.